Hey guys, I want to finish up this set and let's just talk about what we've done so far. We have done mole to mole problems where we were provided with a number of moles and then we calculated moles of something else. We have done mole to mass problems. And also we should understand that we could do mass to mole problems. But here is the magic right here. This is the most useful process. Mass to mass. I have so many grams of something and I want to know how many grams of something else I can produce with that. Or I need to produce a certain number of grams of product, so how many grams of the reactants must I go get? This is the most helpful stoichiometry problem that we will do. So let's put one to use here. This is on page 377 in your textbook. This is actually how your airbag works in your car. So we want to, it says, one of the reactions used to inflate automobile airbags involves sodium azide, NaN3, and then this is the reaction. And they gave us the balanced equation for this. And the question is, determine the mass of nitrogen produced from the decomposition of 100 grams. Actually, it was 100. I'm going to write that again. 100.0 grams. When we have 100.0 grams of this, how many grams will we get? So here's what we're going to see. We're going to have to take this number of grams and we're going to have to convert it to moles, and then do a mole transfer, right? And then come back up out and get the number of grams. That's kind of the process that we need to think about what we're doing here. So as we go along, I'm going to write mass on the top and moles on the bottom. I didn't do that in the first problem, and I apologize for that. So let's see how we do this. Now, what do we start with? Well, the only number that they gave us was 100 grams. So that's where we have to start our math path. So 100 grams of NaN3, the sodium azide. Now, we have to convert that to moles. So we know how to do that from our last chapter. We know that in order to convert 100 grams of moles of sodium azide into moles, that we say 1 mole of NaN3 has what molar mass? Well, now we're going to have to go do the molar mass of sodium azide. So let's do that very quickly. Sodium is, according to our periodic table, is 22. I'm going to do this to the side here. Sodium is 22.99. That's sodium. And 3 nitrogens. Each nitrogen is 1401. So the sodium azide is 14.01 times 3 plus 22.99 equals 65.02 grams. Notice it's not 2 moles, it's 1 mole. This is from the periodic table, right? Just like we did before in our last chapter. So now grams of NaN3, now grams cancels. So we've done that part. Now we want to change the conversation. How do we change the conversation? We do that with the mole ratio. 2 moles I'm going to run out of room, N3 over 3 moles of N2. I should have left myself more room. And their mole cancels. And then now we're going to convert back to grams. Go from mole to gram. How do we do that? 1 mole of N2 has a mass of 2802 grams. I'm so sorry that you cannot see that. So 100 divided by 65.02 times 2 divided by times 3 divided by 2 times 2802. All right, let's run those numbers. 100 divided by 65.02 times 3 divided by 2 times 28.02 equals 64.64. I can have 4 sig figs grams of N2. That is the final. Mole cancels. Mole of sodium cancels. Mole of sodium. Mole of nitrogen. I am too tired to be making this video. Okay, so that's how we do a mass-to-mass problem. All right? So let's do another one together. Actually, I'm going to give you the words and let you take a look at it. And you can pause the video. Okay. The Titan rocket uses a combination of hydrazine, N2H4, and dinitrogen tetroxide, N2O4, as rocket fuel. The reaction is, and we've already been provided with a balanced equation, 2 N2H4 plus N2O4 yields 3 N2 plus 4 H2O. All right, so that is the reaction. Now it says if 200 grams of hydrazine, remember which one is hydrazine, is used, how many grams of water? Gram. This is a mass-to-mass problem, so we've got 3 steps to take care of. All right, so you pause the video, see what you can do with this, and then join me when you're ready to move forward. Okay, so this is 200 grams of hydrazine, 200 grams of hydrazine, and we're going to need to convert that to mole, right? And then what is it we're trying to find out? Water. We don't care about anything else here. We're ignoring everything else. So then I'm just going to draw a line there. I'm going to need to know how many moles of water, and then my answer will be how many grams of water. Now, I'm not expecting you necessarily to make those marks on your balanced equation, but if that will help you, we're also going to draw a graphic to help us with that, that we can use when we're doing our work, and that will help us just like we have our other little graphics. So let's write this out. What do we start with? We start, I'm going to see if I can get us all to fit here, 200 grams into H4. Now, since I have grams, what am I needing to convert to? I need to convert that to moles, correct? So 1 mole of N2H4. Remember, I'm always talking about 1 mole when I'm doing anything with molar mass. So this is grams of N2H4. And I have already calculated that to be 65. No, that was the other one. Sorry. I was doing the one from the last problem. So N2 is 2802 for the N2, and then 4 hydrogens will be 4.04. So 32.06. 32.06 grams in 1 mole. Now, we want to do the mole-to-mole relationship from the balanced equation. Right there, grams cancels. So we put this on the bottom. 2 moles of N2H4, 4 moles H2O. I have to put that so I can change the conversation. So the words do what the words need to do, right? Now, that was my balanced equation ratio. So 1 molar mass, we're mole over grams. Mole ratio, now I'm going to have grams over moles, right? Grams over moles as I come to this last part of the problem. So this is 1 mole of H2O, and 1 mole of H2O has a mass of 18.02 grams. And remember, we know that because we're using for H2O Oxygen is 16 grams per mole, and the 2 hydrogens would be 2.02 or 1.21 for each one of those. So that's how we're going to get that molar mass of 18.02 grams per mole. Now I'm ready to do what we talk about all the time in class. Let's write our equal sign, put our pencil down, and pick up our calculator, because now, whoops, I didn't cancel. I forgot that earlier. I always forget to cancel my last one there. All right, here we go. I'll put the calculator right here. Can we see that? All right, 200.0 divided by 32.06 times 4 divided by 2 times 18.02 equals 224.8. We had 4 sig figs at the beginning, so we can have 4 sig figs here. That 8 would make that go up to a 3, but we have to stop there, so grams of H2O. Now, we also might want to run those numbers one more time to make sure we get the same answer. So 200 divided by 32.06 times 4 divided by 2 times 18.02 equals exactly the same answer. We are good to go. There is our answer to this question.